integration techniques. That's what we're going to work on the next few times here. The next one just happens to be called integration by parts. Let me just put one up here, integral. Here's such a one where substitution does not work. Substitution would not work there. Do you see that it would not work there? What am I going to let x be? There's nothing really out of the ordinary. I mean, I guess I could say u is sine of x, but that'll just give me cosine of x, and it wouldn't get rid of my problem. There's just no way to use substitution there to get this integral. So substitution doesn't always work. However, integration by parts will work on this one. Let me give you the rule, if you will. Here's integration by parts. What we're going to do is we're going to divide our integral into two parts. We're going to call it u and the other part dv. So we do have a u, but we're also going to have a dv. So we're going to divide that up into dv here in just a second. It turns out if you do that, then you can integrate it if you can figure this out. The integral of u dv is going to be u times v minus the integral of v du. Which again, maybe it looks like you're not going anywhere. And sometimes you may not get anywhere with integration by parts, but because you still have to integrate another part here. But the trick is going to be this, we're hoping, is going to be easier to integrate than this. Okay? So that's the whole idea. So it's u times v minus integral of v du. This is just u times v. It's already done, but you still have to integrate this. All right, so let's see how it works. This is integration by parts right here. Or this is really what you need to remember. Because what we're going to do is we're going to take this x sine of x dx. Let's go over here so I can have a little more space to finish this out. What we're going to do, if we're going to use integration by parts, is I'm going to pick part of that to be u, and then the rest of it's going to be dv. And the idea is, again, to get the v du stuff to be a better integral. Well, it just so happens this is set up just like I want it, because I'm going to let u be this, the x, and then the rest of it is dv. And so dv is not going to just be dx. dv is going to be, usually, dv is going to have some other part to it. Okay? All right. So what you do is, again, we're going to kind of start it like u substitution. We're going to just say, the u is the x, and I'm going to get the du, just like I got du with substitution. What would du be here? Just dx. Yeah, the derivative of x is 1, so du is just going to be dx. There's a second part, though, that goes with that. The second part is, we've got this dv equals sine of x dx. And so we're going to have to do a little bit of that, because notice what else I need to put it into this parts. What do I need? I need v. And we're going to get v out of dv. And we've got du. We're going to have to use du. And I've got u. The only thing I'm lacking here is v. It goes two places. The way I get v, like I said, is out of dv, because look at this. Think about this. What would happen if I integrated both sides of that? Well, if I integrate just dv, integrate it in terms of v, what is the integral of dv? It's v. Yes. Okay. Yes. To get v out of dv, I integrate it. With me? Or antiderivative. I get v. Now, what's the integral of sine of x dx? Cosine? Negative? Negative cosine. And so that's the other trick to it. This, whatever you assign dv to be, it better be something you can do the antiderivative of pretty well, or you just run into the same problem. Okay? With me so far? So we've got u, and we also have to get v. All right, so then it's just plugging these in. And this is where I may not have it. Okay. To this. This over a little bit. Okay. So, all I have to do to finish this out is plug all these things in appropriately to uv minus integral v du. All right, u times v, that's just taking u times v. So u is x, v is negative cosine of x. Let's multiply those together. Then I'm going to put the rest of it in. The rest of it is the integral of v, which is negative cosine of x. du is dx, and that works out pretty good. Because don't I have here minus x cosine of x plus the integral of cosine of x dx? That second part is just the integral of cosine of x. I can do that, right? I can do this integral. That's an easy integral. And this is just as is. There's nothing to do with it. Just plug it in. What's the antiderivative of cosine? Sine. Plus c. So it turns out this integral comes out to be that. And since I didn't explain that. Okay, question? What? This, what part? The du, it was just dx. Yeah. Sometimes there's more to it. Yeah. There's more to it than just du being dx. But in this case, it was just dx. Now, just to prove that this works, let's take the derivative of this, because if I take the derivative of that, we should get x sine x, right? What's the derivative of this? Well, the derivative of that would be, by product rule, first part anyway, it would be minus x times the derivative of cosine, which is minus sine, plus cosine times the derivative of minus x, which would be minus 1, plus the derivative of sine, which is cosine. And the derivative of c is 0. Notice what happens. That and that makes an x sine of x positive. Minus cosine x plus cosine of x, those go out. Voila. It works. Okay? All right. So let's do another. The I mentioned that. Okay. Let's try another. Got two more of these. What about the integral of 1 to 2, x cubed ln of x? Can I do it with definite integrals? Sure. We can do this with definite integrals. Now, I'm going to switch it up here a little bit. Because, for one thing, if I let this be u and this be dv, you see a problem? Because think about it. If I did it that, u equals x cubed, and then dv is the ln of x, you see a problem there? Because here's the problem. If I do the integral of that, that's not a very nice integral. The integral of natural log of x. It's doable, but it's not a nice. That's one clue that we may not want to go. No, we're going to switch it around. This case, it's going to work out better if we let u be the ln of x, and then dv is the rest of the stuff, so the dv would be what? x cubed dx? And so on this one I need to get du, so du would be what? Well, it would be the derivative of ln of x, which is 1 over x dx. And then this, well, in this I don't do the derivative, I do the antiderivative, I do the integral. The integral of dv, the integral of x cubed, so that's v, what's the integral there? 1/4 x to the 4th, isn't it? Power rule. So let's see how this works out. Sometimes it may not work out with parts either, but it will this time. So the parts formula is what? It's u times v minus the integral of v du. That's what you have to remember. U times v minus the integral of v du. So in this case, what is it? U times v, so I take ln of x times 1/4 x minus then the integral of v du. That would be the integral v is 1/4 x. 1/4 x du is 1 over x dx. See that? With me? Up to here. Just clean this up a little bit. It's just 1/4, however you want to write it. 1/4 x to the 4th ln of x. Usually they write ln of x last, so let's just do that. Now what about this over here? Well, this is an integral I can do. This is minus 1/4. What about this? X to the 4th times 1 over x, isn't that x cubed? The x cancels, we get x cubed there. Right? A doable integral though, isn't it? I can do that integral because now I don't have the ln of x thing. It's just x cubed. So again, it's just power rule. So the 1/4 x to the 4th ln of x minus, well, the antiderivative here would be, bring down your 1/4, and the antiderivative, that would be another 1/4 x to the 4th, wouldn't it? Then the other part to this, remember, don't forget it, this is a definite integral, so I want to go 1 to 2 on that. So that would be 1/4, 2 to the 4th is 16, ln of 2, minus, this would be 1/16, 2 to the 4th is 16, minus, plug in 1, that would be 1/4 ln of 1, minus 1/16 times 1 to the 4th is 1/16. Clean that up a little bit. This is 4 ln of 2. That's just 1, right? 16's cancel. Minus, well, let's just, oh, ln of 1. What's the ln of 1? 0. So that's just plus 1/16. And so 4 ln of 2 minus 1 plus a 16th, that's minus 15/16. There you go. Is that okay? Question, concern, problem? Got one more. Look okay? What about the integral? Oh, this is what we were just talking about. We mentioned this one just a second ago. The integral of ln of x dx looks like a little integral there. Just a nice little simple little integral. But as far as the value of it, what it is, well, you can actually work this one by parts, doing parts. Use parts on this one. Now, it doesn't look like there's enough parts there, but there is enough, just enough here. Obviously, since, unless you want u to be 1, I've got to let u be the ln of x, right? Yeah, it turns out if you let u be the ln of x, and then what's my dv? dv is the rest, so the dv would just be dx. All right, so I need du here, do the derivative. Be 1 over x dx. dv, do the antiderivative, so that would be v equals what would v? Equal x, yeah. Okay? Look okay. All right? So let's put that to the uv integral v du stuff. What have I got? uv, so that would be ln of x times x. Right? Minus the integral of v du. So that would be minus the integral 1 over x dx. v is x, du is 1 over x dx. Hey, that's pretty nice. This is x ln of x minus, what is this? Well, the x is canceled, so yeah. I'm just going to do the integral of 1 dx, which is x plus c. So it turns out the antiderivative of ln of x is, well, a little longer than you might think, but that's what it is. Okay? It's by parts. Oh, no, I've got one more. Do I have time for one more? Yeah. I do have one more. Sorry about that. So I'll get you to help me out with this one, all right? Yes, because I do need to make a point about this one. Integral x squared e to the 2x dx. All right, so I'm going to tell you it's parts. Which parts do you want to be the parts? U to be e to the 2x? You would pick u to be x squared? Okay, yeah, I see you're thinking there. However, yeah, it's you. And you just have, I mean, it's, yeah, I mean, just, I see what you were saying, and you can try that, but it turns out you are going to want, because it turns out integrating e to the 2x is not that bad, right? An e to a power is not that bad of integral. You have to do a little u substitution. Yeah. But yeah, if you try it one way, flip it around and try it another way. That is a little point here. Okay. So u is x squared, dv is e to the 2x dx, du is 2x dx, and then integral here. Yeah, this is just a little u substitution, right? Because simple substitution, I like to call it. Simple if you see it, I guess. But du is 2 dx, so you have to wind up doing d over 2 for dx. So, yeah. It's 1/2. It turns out it'd be 1/2 e to the 2x, wouldn't it? Is what v is. You with me there? So, just because we're using parts doesn't mean we can't use substitution. We may have to use u substitution. Matter of fact, I think we're going to have to use u substitution again. So, just warning you there. All right, so it's uv minus the integral of v du. So it's u x squared v 1/2 e to the 2x. That's that part. Minus the integral v is 1/2 e to the 2x. du is 2x dx. Well, the good news here is the 2x. The bad news is, look what I got. What I have here, well, it looks vaguely like what I started with. However, what's better about this than what I started with? It's not x squared, it's x. So I did lose one power here, and so that's good, because if I maybe do it parts again, it'll get me to where I want to be. Okay? So I have to do parts again. So you can do multiple integration by parts. Now this one's just going to come along for the ride. But the parts here, u, well, we're going to do the u is x again, and dv then is 2 to the x dx. E to the 2 to the x dx. So du is dx. Integrate that, well, it's the same integral I had before, so v is 1/2 e to the 2x again. Wasn't that what it was? Yeah. So we did substitution again, but it was the same substitution, so we're not even going to count it. All right, so what have I got? Well, this one just comes down. Don't forget it. It's 1/2 x squared e to the 2x. Now, this is minus, but I'm going to do the parts again. So it's going to be minus uv minus integral v to u. So what's going to happen there? Well, it's going to turn into minus uv and plus v to u, right? Because it's behind the minus. So that's one thing to be careful about there. So this is 1/2 x squared e to the 2x minus uv, so it'd be x 1/2 e to the 2x minus the integral of v to u 1/2 e to the 2x times du is dx. Do you see that I'm home free here, basically? Because now, can't I do this integral? Because it's a u substitution. It's again just a u substitution. U is 2x du, so it's going to be the same thing, so we got the half. So here's what it is. You got 1/2 x squared e to the 2x minus 1/2 x e to the 2x, and that'll be plus, what is this going to be? It's going to be 1/2 times another 1/2 e to the 2x. Isn't that what it's going to be? Plus c. One-fourth? This will be 1/4. I don't want to write that all again, so I'm just going to say it's 1/4. 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x plus c. Questions or concerns? Okay. Do this one again? Okay. Well, it's a lot like this one, except it's the very same